All right, 7.4. We're going to be talking about the parent graph of a logarithmic function. And remember, logarithmic function. How do I know it's a logarithmic function? Because it has the word log or ln in the expression, right? Pretty simple. Here's your objective. You will be able to graph exponential and logarithmic functions showing intercept and end behavior. In the previous videos, we have talked about exponential functions already. What they are, exponential growth, exponential decay, and we're graphing all that. Now we're going to look at the logarithmic functions. Okay, now for logarithmic functions, you have vertical asymptotes. For exponential functions, you have horizontal asymptotes. So logarithmic is the inverse, so therefore the inverse of horizontal is vertical. Okay, and here are what your logarithmic functions look like. You know, either they're increasing or they're decreasing. Okay, so how do I know which one is which? Again, it all goes back to the b, the base of the log. If the base is greater than 1, like here, that means as I approach 0, as I get closer and closer to 0, I go to negative infinity. Or as x approaches positive, this is not here though. So for b is greater than 1, if x approaches positive infinity, in other words, if I go to the right, and I keep going to the right, my y value keeps increasing. So that means then y approaches positive infinity. That's one way of looking at it. Now b is less than 1, but greater than 0. So it should be greater than 0. As you approach x, as x approaches 0, in other words, if I'm going towards the origin, you notice my y value goes to positive infinity. Okay? Or, again, if I look at it one the other way, so if I start here and go to the right, so as x approaches positive infinity, as in other words, I'm going to the right, y approaches negative infinity. In other words, it goes down. The y value goes down. Okay? So there's two ways of looking at these interpretations. All right? But the main thing is this. If b is greater than 1, it's increasing. If b is less than 1, then it's decreasing. Okay? Also, my y-intercept will always be 1. Not my y-intercept, excuse me, there's no y-intercept. The x-intercept, all right, because we're dealing with the inverse. Because for exponential, you have a y-intercept. So if I do the inverse, logarithmic, so exponential function, you have a y-intercept. Logarithmic function, you have a x-intercept. Right? And just like the y-intercepts in the previous exponential function we did, that it was at 1, or whatever a is. It's the same thing here for logarithmic, but this time it is an x-intercept. So let's graph these, all right? We are graphing. The x-intercept is at 1. Here's my vertical asymptotes. That means I cannot touch or cross this line right here. Now we look at b. Is b greater than 1 or less than 1? Well, it's greater than 1, so therefore my graph will be this. Okay? That's it. It's a curve. There's no squigglies in it. There's one solid curve going through 1 on the x-axis. And the last example, all right? Again, here's my vertical asymptote, so I cannot touch this line or cross it. My x-intercept is at 1. B is 1/4. So if but that's less than 1, so therefore my graph is that. That's all there is to graphing logs.